Unit 4 is all about statistics. We're going to be looking into dot plots, histograms, box plots. We're going to be looking at the shape, center, and spread to talk about sets of data and describe the data set. We're going to be looking at two-way frequency tables. And finally, we're going to look at linear regressions and finding a way to get a line of best fit within a scatter plot. A lot of what we're doing in this unit should be reviewed, but there are some new features as well. So the first one, we're looking at a runner recording the time in minutes it takes her to run a mile on 30 different days, and the times are shown in the table. We want to sketch a histogram, but we don't want to do this by hand when we have technology at our fingertips. We have a lot of different options available. We can use Desmos, we can use our graphing calculators. Today, I'm going to use the graphing calculator, the TI graphing calculator, to do this. Later, you're going to press the Stat button. Then we want to edit. So we just want to press Enter on Edit. And then we want to enter our data points in list 1. Now, I kind of worked ahead. I actually already put these points in my list 1. And to do so, you just type them in. 7.4, 7.5, 7.8, and so on until you have all 30 data points entered into list 1. If you haven't done so already, please pause your video and enter those data points now. Once you have all the data points listed, we're going to press second, y equals. We're going to press enter for plot 1. We want to make sure that the cursor is on the word on and it's highlighted. For the type, we want it to be the histogram right here. It kind of looks like a box graph, a box. And then the XList should be L1. Then I'm going to look at my window. Well, I know that all of these running times are between 7 and 11. So I said that I want my X min to be 7 and my X max to be 11. I didn't want to just count by ones because these are pretty close together, so I counted by half. Then when you look at your graph, you have a very nice picture of what this should look like. And if I press trace, I can see that from here, these are between 7 and 7.5. So moving over to my picture, I want my first box to be, it goes up to 3 on the frequency. I'm just going to drag it right down here. And this is from 7 to 7.5. My next box, as I move over, that one has a frequency of 10, and it's from 7.5 to 8. So I'm going to pick another box, frequency of 10. Okay, that looks pretty good. They're kind of overlapping, so I need to slide it over just a little bit. And there we have it. This one goes from 7.5 to 8. Looking at my calculator, the next one goes up to 8, and it's 8 to 8.5. Trying to keep the bars on my bar graph, my histogram, even. This is 8 to 8.5. The next one goes up to 6, and it's 8.5 to 9. The next one only goes up to 2. and that's 9 to 9.5. Then there's a gap where there aren't any, and then I have from 10 to 10.5, there's 1. So this is 10 to 10.5, and this would be 9.5 to 10. So now we have our box plot, our histogram rather, and we would say that this is roughly skewed to the right. If I try to connect the tops of these under a curve, do you see that it's not a balanced, symmetric curve right down the middle? It looks like I took the right side of this and pulled it to the right. That means that this is skewed to the right. Because most of the data is on the left. Now, the outlier is the number that kind of doesn't belong. It's not like the other numbers. Kind of like this number right here. If I were to remove that, what happens to the data? How does that affect things? So let's look at that on our calculator. I'm going to go into Stat to edit, and I'm going to scroll down to the bottom of this list where I typed the 30th number, which happened to be my outlier. It's not like the rest of the numbers. There aren't any other numbers like in the tens. So I'm going to delete that one. Now I'm going to look at my graph again. Now it doesn't quite go up as high. In fact, I could even adjust my window. Now all my numbers are less than 10. And you can see that it looks a little bit more normal, a little bit less skewed when I do it that way. It's still a little skewed to the right, but not as much. Now we're going to make a dot plot. You've probably made many of these before. We're going to take and put a little circle or an X. I'm going to use an X because it works better with my computer. And we're going to do a frequency line plot or dot plot. So at the number 6, I'm going to record that, and then I'm going to mark it off so I know that I've done it. 8, 9, 5, 6 again, so I go above it. Then I have a number 8 again, 12, 0, 6 again, 8 again, 4, and another 8. So we have represented this data using a dot plot. Now we're going to look at the box and whisker plot. With the box and whisker plot, it's going to have a box in the center with a line down this, not necessarily in the middle, but somewhere inside the box. Then there's going to be a tail to the left, or a whisker, and a tail or a whisker off to the right. This lowest point right here is the minimum. So our minimum is 5, and our maximum is going to be 9.5. The median is always right here in the center of the graph. The center of the box is the median, so in that case it's a 6. The first quartile is going to be the left side of the box, which in this case is 4, and the third quartile is going to be right here, 7.5. The median can be called quartile 2, Q1, Q2, Q3, but it's also the median, so we'll just call it the median. Let's look at how we can use box and tail graphs to analyze some data. when we look at these box and tails, the first tail represents 25% of the data. The left side of the box represents 25% of the data. The right side of the box represents 25% of the data. And the right tail represents 25% of the data. So looking at these, we know that the median of Miguel's data, which is right here, is what compared to the median of Shona's data? Well, Miguel's median is greater than. Miguel's median is 40 and Shona's median is 35. 40 is greater than 35. The range is going to be found by subtracting the max and the min. So Miguel's range is going to be 55 minus 25, which is 30. Shona's range is going to be 60 minus 25, which is 35. So the range of Miguel's data is less than the range of Shona's data. Approximately what percent of Miguel's data values are greater than the median of Shona's data? So here's Shona's median right here. I'm going to put a line down all of it. How much of Miguel's data is greater than 35? Well, we'd have 25% here, 25% here, 25% here, for a total of 75% of Miguel's data. They are greater than the median of Shona's data. All right, now we're going to find the mean and the median. In order to find the mean, we want to add all of these numbers up and then divide by how many there are. 1, 2, 3, 4, 5, 6. Divide by 6. Now, we can do that with a calculator by hand rather easily. We can also make the calculator compute it for us. If we enter these numbers by pressing Stat, Edit, notice I put mine in list 2. Now I can press Stat, Calc, Enter. I have to tell my calculator I put it in list 2. And it will tell me the mean. It'll tell me, if I scroll down, the median. It tells me all of these things. So flipping back to my calculator, because I want to write that number down, the mean tells me actually more than I even need, is 218.7. 218.7. That's the same number I would get if I were to type these all in and add them up and then divide by 6. Now the median, we need to put the numbers in order from smallest to largest, and they're actually listed that way. To find a median by hand, you're going to take off the smallest and the largest, the next smallest, the next largest, until you're down to 2 numbers or 1. 1, that's just your median. If there's 2 numbers, we need to average these. If I add 226 and 216, I get 442. Divide that by 2, and I get 221 for my median. But notice the calculator got that same answer for me, 221. And then you don't even have to do the actual arithmetic. All right, the next one we have a list of data. Now they want us to find the mean, the median, which we just did on the last problem. But this is a longer list, so I definitely want to use my calculator this time. So you press Stat, Enter for Edit. I'm putting mine in list 3, but you don't have to keep using a new list. It just worked best for me so that I could have all my numbers in here. Feel free to pause the video and enter those 16 numbers. Now that you have the numbers entered, we're going to tell the calculator to figure out the mean, median, range, interquartile range, and the standard deviation for this list of data. We're going to press Stat. We're going to go over to Calculate. Option 1 again, one variable statistics. I need to tell my calculator what list to use. Mine was in list 3. So I hit enter. You can see the mean is 76.5. On the calculator, it's listed as X with a line over it. The median, I need to scroll down to find the median. It's 77.5. The range, if you recall, is the max, take away the min. So I need to use my calculator. What's the max? 100. And what's the min? 50. So 100 take away 50 means my range is 50. The IQR is the interquartile range. Which means I want to take Q3, take away Q1. Not the max and the min, but a little closer to the median. Q3 is 87.5, Q1 is 69.5. And when I subtract these, I get 18. And then the standard deviation is going to be the SX number, 14.7. Now, depending on the data, depending on the shape of the data, that tells us what kind of statistics we want to use to describe the data. If we graph our data and the shape is normal, that means it's not skewed. It's a nice curve. Then our center is going to be the mean. And our spread is going to be the standard deviation. If my shape is skewed to the left or to the right, my center is going to be the median, and my spread is going to be the IQR. So it depends on how your data looks, which of these statistics you would use to report about the data. All right, let's match. Which one of these looks symmetrical? The first one. Which one has the tail that's been pulled to the left? This one. This is our left skew. And this one is our right skew. Now let's talk about some two-way frequency tables and some conditional probability. A math teacher researches the relationship between 7th and 8th grade involvement in speech and debate and drama club. Given that a student is in 8th grade, what percentage of those students participate in drama club? Whenever you see these magic words given that means we have a limited amount of the data that we're going to look at. We know that the student is in the 8th grade. So out of all the 8th graders, how many are in drama club? So that means we're just looking at the 8th graders right here. We're just looking at the 8th graders. How many 8th graders are there altogether? 20, 40, 40. So out of 40 8th graders, remember we're just looking in this column now. How many are in drama? 21. Using my calculator, we would say 21 divided by 40, which gives us 52.5%. Let's complete the table now. In the last table, it was completed for us, but let's try to complete this table together. Here we're looking at math, science, English, and social studies, and we're looking at 9th and 10th graders. Well, if there's a total of 10 people in the math class and 7 are in 10th grade, that means 3 are in 9th grade. And in science, if 29 are in 9th grade and 11 are in 10th grade, that means 40 take science altogether. In English, there's 30 English students, 23 are in 10th grade, that means 7 are in the 9th grade. In social studies, we have a total of 20 students, 11 9th graders and 9 10th graders. Now, going across each row, 3 plus 29 plus 7 plus 11 equals 50. 7 plus 11 plus 23 plus 9, let's see, that's 20, 43, that's also 50. 50 plus 50 is 100. Let's check going this way. 10 plus 40 is 50, plus 30 is 80, plus 20 is 100. The joint relative frequency a 9th grader liked math. Okay, so what is the probability that a 9th grader liked math? Well, the first thing we need to talk about is what joint means. In our two-way frequency table, math meets 9th grade, that's a joint frequency. Science in 9th grade, English in 9th grade, social studies in 9th grade. All of these values here, where the different columns and rows intersect, are joint frequencies, versus the ones here around the edge, or the margins, are the marginal frequencies. These are the totals for each of the categories. The total 9th and 10th graders, the total of each subject. Those are going to be the marginal. So the joint relative frequency that a 9th grader liked math. So we know the student is a 9th grader. How many 9th graders are there? There are 50. Of these, how many liked math? 3 out of 50. Using our calculator, 3 divided by 50 gives me 6%. The marginal relative frequency of 9th graders. So how many 9th graders were there? 50%. Finally, given that a student was in the 10th grade, so let me get rid of some of this highlighting so we can look at this next part. Given that a student was in 10th grade, so I know I'm looking at this row. How many students are in the 10th grade? 50. So I know it's out of 50. What's the likelihood they preferred English? English will be right here. 23 out of 50. When I use my calculator, 23 divided by 50, I get 46%. Given that the subject was science, so now we are starting with science. Given that it's science, that's a total of 40. What's the likelihood that the student was a freshman or ninth grader? 29 out of 40. Using my calculator, 29 divided by 40, I get 72.5%. Here's another two-way frequency table. And we have given that a student took a math test, so we're going to look just at the total number took math. That total number is 32. So out of 32 students, what percentage of those did not pass? That would be 12 out of 32. Using the calculator, 12 out of 32 gives me 37.5. Alright, moving on to our next question. Was finished. Let's talk about lines of best fit. Which line best fits the data? Well, if I take the first line that says begin at 10 and go up 3 over 1. So if I begin at 10, up 3, over 1, based on the scale of this, would look like this. Does that fit the data? That one's not too bad. What if I begin at 20 and go up 2 over 1? So if I go up 2, that's 20 over 10. Up 2 over 10. That would fit right here. That looks really good. That looks even better. Let me take green for this one. Begin at 30 and go up 3. So if I go up 3 blocks, that's like going up 30 over 10, up 3 over 10. That one looks a little high. And then this one says begin at 20, go up 1 over 1, up 1 over 1. That would be a little bit low. Let's check the first one again since I didn't keep that one on here. That says begin at 10, go up 3, so that's up 30 over 10, 30 over 10 would look like that. So I think we can agree that the green line is too high, so we don't want that one. We can probably agree that the red line is a little too low, so we don't want that one. But between the blue and the gray, which one is the best fit? Well, that's where we have to look at the number of dots on either side. So the blue line looks like it goes through about 3 of them, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 above, and 1, 2, 3, 4, 5, 6, 7 below. Looking at the gray line, 1, 2, 3, 4, 5, 6, 7, 8, 9 below, and 1, 2, 3, 4, 5, 6 above. So both are pretty decent lines of best fit. Okay, looking at this, we want as many points as possible to be on the line, and we want an even number of the points not on the line to be above and below it. So looking at these two options, the gray line has more points on the line, and 7 and 10 is a more even split of the points that are above and below, versus the blue line. There's only 3 points that are on the blue line, and 10 and 7 isn't as even of a split as 7 and 9. So our best answer choice is A. looking at the next one, we're going to create a scatter plot. Hours worked is going along the x-axis, and number of candy bars is going to be on the y-axis. So the point 2.8 is our first. 2.8. Point B is 412, so we go over to 4, up to 12, put a point. Point C is 614. Point D is 818. Point E is 1020. Point F is 1220. Point G is 1422. So there's our scatter plot. Okay, now let's figure out the best equation for this line of best fit. We're using the 2 points that are blue that are on the line. So when we write an equation of a line, if you recall, y equals mx plus b, this goes back to unit 2, we need the y-intercept, which appears to be around 3.6. Probably be approximately 11/3. So we think the y-intercept would be about 11/3. The slope, let's count it. We go down 1, which means -1, and then we go over 1, 2, 3. So we're looking for an equation that matches that, which is right here. Alright, how many hits could we expect from a player at bat 175 times? At bat is the x value, because it says under the definition of the variables here, x is the number at bat. So y equals 0.32 times 175, take away 20.51. This will give us the number of hits. Using our calculator, 0.32 times 175, take away 20.51. We should expect about 35.5, so 35. Final answer. Okay, the number of people who watch a television show and the number of oranges sold at a grocery store. Does one affect the other? No, they're not related at all. It's not like if people watch more TV, they're going to run out and buy more oranges. There's no correlation between those two categories. Let's match the scatter plots with their correlation coefficient. The correlation coefficient is basically a description of how nice of a line these points make. If it's a positive correlation, the points will make a positive slope. If it's negative, they will make a negative slope. So for the first one, this would be no correlation. I can't tell if they make a positive trend or a negative trend. Here, they're pretty much in a straight positive line, so r equals 1. And this would be r equals -1. Remember, we're just using these answer choices. And we've made it to the end. That is it for Unit 4 on statistics.